In this video, we'll be talking about the quotient rule, the rule for finding derivatives of a quotient. The rule is the derivative with respect to x of f divided by g is g times the derivative of f minus f times the derivative of g, all divided by the square of g. So when we're doing our quotient rule, you start with the denominator, and that gets multiplied by the derivative of the numerator, and then subtract from that the product of the numerator times the derivative of the denominator, and then square the denominator. Now, if you like a mnemonic to remember this, it is low d high minus high d low over the square of what's below. So when we say low, that's our function in the denominator, and d high means the derivative of the function that's in the numerator. So we have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the square of the function in the denominator. Let's do a few examples. Our first one, we're asked to find the derivative of each of the following. And so this is obviously a quotient. So we'll need to use our quotient rule. So y prime then is, and I always put my denominator squared in the denominator of the derivative just so that I don't forget it. But I want to start up here in the numerator with the bottom, so x squared plus 1 multiplied by the derivative of the numerator, so multiplied by the derivative of 5x minus 2. And then I'll subtract from that the numerator, which is 5x minus 2, multiplied by the derivative of the denominator, which is x squared plus 1. So now we just need to do the derivatives here and then simplify. So y prime is equal to x squared plus 1 times, and then the derivative of 5x minus 2 is just 5. Subtract, and then 5x minus 2 times the derivative of x squared plus 1, which is just 2x, all over x squared plus 1, quantity squared. So let's distribute. Y prime is equal to 5x squared plus 5, and then I'm going to distribute a negative 2x through this binomial. So a negative 2x times 5x is a negative 10x squared, and then a negative 2x times a negative 2 is a positive 4x, all over the square of our denominator. So we can combine like terms, and we get y prime is equal to negative 5x squared plus 4x plus 5, all over x squared plus 1 quantity squared. Do one more. Now before I start the derivative of this, I would simplify this complex fraction. So let's multiply top and bottom by x to simplify the complex fraction. So we get f of x, this is just a rewrite, is equal to 3x minus 1, because the x's cancel, over x squared plus 5x. So our derivative then is, and I'm sorry, that could also be written this way. My denominator is x squared plus 5x, and it'll be quantity squared. I start with the bottom, so I have x squared plus 5x multiplied by the derivative of the top, which is just 3. Subtract from that the numerator, 3x minus 1, times the derivative of the bottom, which is 2x plus 5. I need to simplify this. I'll distribute this 3 through the binomial. So 3x squared plus 15x. And then I'm going to use FOIL to multiply these two binomials, and then I'll take this negative through in a second step. So 3x times 2x is 6x squared. 3x times 5 is 15x. And then negative 1 times 2x is negative 2x. And then negative 1 times 5 is negative 5. Now let's distribute this negative. I'll copy the other. Be a negative 6x squared. These two combine to give me 13x. So the negative makes it a negative 13x. And then plus 5. And then finally, this is negative 3x squared positive 2x and positive 5 over that x squared plus 5x quantity squared.